All right, hello again, ladies and gentlemen. I forgot to, or I didn't go over problem 5A on the previous video, and I wanted to just go over that real quick now, because after reading it and reading some of your questions, I realized this is actually a pretty important concept. So this question asks us to find the values of g of 3 and g of -2. Now, we're not given an actual function of g, but we are given a graph of g prime, and we're given an initial condition for g. We're told that g of 0 is equal to 5. The rest of this problem deals with the concept that you see here, that a function evaluated at a certain point can be expressed as that function evaluated at some initial point plus the integral from that initial point to the point we're interested in of the derivative. And remember, this expression, this integral expression, when you integrate a rate, that tells us the net change in f from x equals a to x equals b. And that's what we want. So we know what the value of f is at a, and then we want to add to it the net change from a to b. So if we have the value of f at a, and we add the net change in f from a to b, then we'll have the value of f at b. Another more explicit way of thinking about this is, well, if I explicitly write out or evaluate this antiderivative, or this definite integral, I should say, fundamental theorem of calculus part 1 tells us that this will be equal to f of b minus f of a. Well, if I take f of a and I add to it f of b minus f of a, what am I left with? I'm left with f of b. So this is just sort of proving to you that if I want f of b, I can take f of a and add to it the definite integral of the rate from a to, and I can add to it the definite integral from a to b of the rate of the function. All right, so let's put that into practice here. So g of 3, in order to find g of 3, I'm going to take my initial piece of information and I'm going to add to it the net change in g from 0 to 3. And that, of course, the way we do that is we integrate g prime from 0 to 3. Now, how do I find the value of a definite integral if I'm not given a function? Well, we are lucky enough to be given the graph of g prime. And so all I need to do is find the area under the curve of g prime from 0 to 3. And that is this area right here. So the area under the curve, and we are moving from 0 to 3. So we're moving from left to right. So our dx's are positive. And since each of these heights are positive, that means the area we're going to use for our definite integral will be overall positive. So my final answer for g of 3 is the original 5 plus pi plus 3/2, which is the net change in g from 0 to 3. All right, so that's g of 3. And the next question is g of -2, which is a little more tricky because now we're starting at 0 and we're moving to -2. And so our dx's are going to be negative, but our heights, let's see if I can change the color here. Yeah, okay. The heights are still positive. So my integral, if I'm integrating from 0 to -2, in this situation, my dx's are negative, my heights are positive, so the definite integral is going to be overall negative, right? The areas of those rectangles are positive heights times negative widths, overall negative. So g of -2, I'm still going to start at my initial condition, which is g of 0, but then I'm going to add to it the integral from 0 to -2 of g prime of x dx. These dx's are negative. So since the area is pi, I'm going to take the negative version of that because, again, negative dx's. And so my final answer is just simply 5 plus negative pi, or of course 5 minus pi. All right, so that was the addendum. I hope that helped, and take care. Bye.